Good evening all. Let us start with the third unit, which is resonance and coupled circuits. In unit 1 and 2, we would have dealt with DC and AC circuits. In unit 3 and 4, we are mainly going to concentrate on AC circuits, where the quantities will be varying with respect to time. So the outline of this presentation is as follows. We will start with seeing sinusoidal voltage and current. Then we will see the average and RMS value. Then the voltage current relationships for various parameters. Then we will see what is power factor, and we will see what is impedance. So starting with the sinusoidal voltage and current, till now we know that the DC voltage is represented as V and DC current is represented as I. But when we represent sinusoidal quantities, the voltage and current will be sinusoidally varying with respect to time. So we will be writing voltage as Vm sin omega t, where Vm is the amplitude or the magnitude of the voltage, and this is the sinusoidal distribution with respect to time t. Similarly for current I, we will be writing as Im, which is the magnitude of the current, and sin omega t represents the sinusoidal variation. To define the individual terms present here, Vm and Im correspond to the magnitudes, whereas omega is called as the angular frequency. This is a new term that we get introduced. We know what is frequency. Frequency is represented as f, and we introduce a new term called as angular frequency, which defines the frequency f in terms of radians, that is 2 pi. So therefore, the relationship between angular frequency omega and frequency f is given by omega is equal to 2 pi f, and the unit of this is radians per second. And to define what is frequency, the number of cycles per second. For example, we have the time from 0 to 1. Then for this, there is one total revolution. So we will call the frequency to be 1 Hertz. For example, for 1 second, this is my time from 0 to 1. The number of revolutions are 1, 2 and 3. Then my frequency is 3 Hertz. So frequency is nothing but it is the number of revolutions per second. And number of rotations. So this is one rotation. We call this to be 1 cycle. So these are the new parameters that we get introduced to. We need to know what is frequency. It is the number of revolutions per second. We need to know what is a cycle. We need to know what is angular frequency, which is 2 pi f. And we know that time can be obtained by inverse of frequency, which is 1 by f. Coming to the average and RMS value of voltage. Average value is nothing but it is the value of the voltage for a particular time period. So if we define it to be the average over 1 by pi. So it is 1 cycle, so it is 1 by pi. Integration of 0 to pi V into d theta. Because the variation of your voltage and current are with respect to the angles. So it is V into d theta, and taking the average, so we divide it by 1 by pi. And we know that V is equal to Vm sin theta. So we write V to be Vm sin theta d theta. And this on simplification, we get this to be 2 into Vm divided by pi. The RMS value is nothing but it is the root to 1 by root 2 times of the maximum voltage that is present. So the RMS value V is given by Vm divided by root 2. And similarly, the average value of current, it is 1 by pi, integration of 0 to pi I into d theta. We know I is equal to Im sin theta, which is a function of the magnitude as well as the sinusoidal distribution. So when you take this Im by pi commonly outside, integration of sin theta gives us cos theta from a limit of 0 to pi. Right? So this is minus cos theta 0 to pi. On substituting the upper limit minus lower limit, we will be getting 2 Im divided by pi. And the RMS value, once again, it is 1 by root 2 times of the maximum value. So the maximum value that we have found here, if I divide by root 2, what we get is the RMS value of current.